Good afternoon, people. I've got an Amazon tablet here. It's already been opened and a shield has been removed. Amazon, that's all. Don't know what model it is, and I'm not going to bother digging to try and find out the exact model. Anyway, the symptom is that it's dead. It's just completely dead. So what I'm going to do is I'm going to try and locate the short with the help of the use of thermal imaging camera, which I've purchased a little while ago. So let's see where the problem is. I have tried resetting the SMC and taking the battery out, powering it off, and reconnecting the battery, but the situation is that it hasn't improved. Just trying to look for the app for Flir 1. Okay, let's connect this. We have to sort of sorry, I'm just in the middle of powering up the Flir 1 Pro. Okay, let's connect this. Okay, let's sort of just check. I'm just checking. Let me put you on the thermal camera view. Just sort of thermal camera view. Let's sort of see what's going on. Right. So what is? Sorry. Okay. Just thinking too many things at the back of my mind. Okay. So I've got bench power supply. It's drawing 1.5 amp at least. There was a hot spot around this area. That's why I've taken the shield off. The hotspot was around this area, so that was quite a bit of a nightmare to take. It wasn't low melt solder like the iPhones. This was really, as you can see, these can you see the shade here that's changed? That's because of the excessive heat. So Amazon. Okay, so I did manage to take it off eventually without damaging the component, which the board had to come off because there's a battery, and I'm glad I took the board off because of the excessive heat that was applying. It would have actually bulged the battery, damaged the battery. Anyway, let's get back onto this. So when battery's connected, nothing's happening. These are the two pins that should power up the unit, but nothing seems to happen. Absolutely nothing. You do have your voltage there. Yeah, I'm using a cheap crappy multimeter. I have my decent ones, but this is a little bit more portable, and I wish big manufacturers like Fluke and Keysights and things like that should make multimeters like dinky multimeters, so it's easier to move about. I'm short of bench space. Let's sort of see what voltage we get on the power switch. So 3.5. Just out, it should be 3.3. So 3.5, 3.595, which if you round it off is 3.6, so it's a little bit more. I'll just get down to the bottom. Right, so what I'm going to do now is I'm going to connect the bench power supply. Bench power supply is set to 5 volt at 2 amp. And let's see what's going on. We'll put you on the let's get this right. Oh, it's this way. And then instantly the bench power supply starts drawing 1 point, which is way beyond its it shouldn't be anything more than say 500-600 milliamp of current draw for charging the battery, but it's way above its threshold. So what I'm going to do now is I'm going to point the camcorder towards the thermal camera. Let me get this in a nice position so you can see it better. Get the marker on the chip so you can also see what temperature. So this is the suspect. That is the suspect. Zoom in a little bit. No, it'll distort the image. So that's as far as I can go. Can I increase the brightness? It won't let me now. No, it won't. So I'll keep it like this, and yep. So that's your hotspot. Let me make a slight adjustment here, just so that we can narrow it down a little bit better. Okay, so here we go. That's the chip. That's developing the shot, nothing else. Now the unfortunate thing is that this chip is not listed. I just can't find it anywhere. So let's get rid of this. I will turn off the I'll move this out of the range. Let's go under microscope and see what this part is. Hope I can get a decent view, hopefully, but I'm not going to make any promises because thanks to vision engineering. Let me get a view first and then I'll sort of see if I can, if anyone's got any ideas about this. Yeah, it's like the only way I'm going to get a clear image is through this. So it's a U700. Basically that's the IC that's shorted and causing the excessive heat. So let's go under the microscope, and that's the IC that's causing the short. Let's so it's that one. My tweezer's gone. And now my tweezers is fucked off somewhere. That is the culprit here. This. So it's not listed. I can't find it. So unfortunately, it's no repair. So yeah, that was just a short video, just to demonstrate how you find a short with the use of a thermal imaging camera. Hopefully I managed to locate. I'll try and manage to locate this IC, but I doubt it very much that it's listed. So I don't know. This is probably going to be a write-off. Anyway, that's all. The main purpose of the video is to demonstrate that this little thermal imaging camera, which is a massive helping hand, because there's things that you can do even with alcohol test. Use of alcohol. Some people use petrol, which is definitely not recommended. Sometimes you'll miss. Sometimes it will not detect certain components that are heating up to a certain temperature. For the alcohol to evaporate, it has to reach a certain temperature. So it is a good idea to utilize, have one of them. They're not expensive. Look around on eBay. You'll pick them up for a silly price versus retail. Retailed at around about £500. You'll pick them up for about, say, 250 quid, 280, something like that, which is almost half the price, and I think it's a bargain, you know. So yep, simple issue. The U700 is damaged on that. That needed replacing. It is a BGA IC, and unfortunately I could not find one. I'll look again, but I could not find one. But that's all. Anyway, have a great weekend, guys. It's Friday here today in the UK. All the best, and I'll catch up with you guys in the next video. Take care.